Consider the following graph. It represents the radial loading acting on the shaft of the pump. As you can see from this graph, the radial loading on the shaft rises if the pump is operated too far to the left or too far to the right of its best efficiency point. Another interpretation of the same concept is to say that the maintenance and problems rise when the pump is operated away from its best efficiency point. Many pumps have a rather narrow operational window. These pumps can be very efficient if they are correctly specified and operated. This was discussed in details in previous sections related to pump curves and system curves. Some pump manufacturers use a different tactic to expand the operating window of their products. This is why the Dual Volute Pump exists. The Dual Volute Pump is designed to operate over a wide range of flows and heads. In the casting procedure of the Dual Volute Pump, a second cutwater is designed 180 degrees opposite the first cutwater, and another volute channel is added. This way, all areas exposed to velocity and pressure around the volute casing are equal, and so all forces around the volute are equalized or cancelled. The second cutwater and volute channel create an additional obstruction to the flow through the pump, and for that reason it robs some energy from the fluid. This will for sure reduce the efficiency to a small degree, but the operational range of these pumps is quite broad, as you can see from the following graph. So this, if you recall, is the radial loading acting on the shaft of the pump for a single volute pump. And here you can see the same graph for a dual volute pump. Notice here that the radial loading profile for dual volute pumps is quite flat, making the operational range of these pumps quite broad. The dual volute design casing is an optional cost accessory with some pump companies and offered standard with others.